Alright, for this problem we're going to find the center of mass of a thin plate. The plate will be, again, of uniform density. So we have a plate of constant density. Delta. And in our previous we've seen that if the density is constant, the delta factors cancel out. But we'll keep this in. And the plate is bounded by the function y equals 7 secant squared x. And the x-axis, and it's bounded by x being trapped between negative pi over 6 and pi over 6. And this will give us some good symmetry arguments that we might want to take into account here. So if I draw this plate and we draw the secant squared function on it, that's going to be 7 because secant squared will always be positive. When cosine is 0, this is 1 over 1, so 7. And it very steeply rises. And there are asymptotes at pi over 2 and negative pi over 2. But it will be very steep when it approaches them. And then we're going to look at pi over 6 and negative pi over 6. So it has these really large arms up, right? Like Loki's helmet. It has these horns that we want to look at. I'll start my rectangle that we'll use to do our integrations. But I think we can note that this being a symmetric across the x-axis, that our x center of mass will be 0. Right, however far I move over on this side, there's an equal element on the other side that will always balance out. And because these are the same endpoints on a symmetric about the y-axis, our x center of mass will be 0. So what we need to do is we need to find y bar, which is the moment about the x-axis divided by mass. And so our mass will be our dm integrated. And so we need to work out dm. And from there we can build our other rectangles. So this is our setup. We already have one of the coordinates. We know x is 0, so we really need to focus on mx, the moment about the x-axis and the mass function. So our dm, as usual, is the density function times the area. And if we look at our little rectangles, our area is going to be delta x times the function itself, or in our case, dm is going to be 7 delta secant squared of x dx. This means our mass integral will be integrated from negative pi over 6 to pi over 6 of 7 delta secant squared x dx. And our moment about the x-axis, right, we'll integrate y tilde, and y tilde is, if we look at that, y to dm. So y tilde is the function divided by 2. So if we substitute that in, we're going to have 7 halves secant squared x dx times 7 delta secant squared x. Whoops. There's no dx on that part because y tilde doesn't have a dx in it. Dx. From negative pi over 6 to pi over 6. And mx we can simplify. We'll pull out 49 halves from negative pi over 6 to pi over 6. And I guess we'll pull out and the delta, and we'll pull out the 7 delta from negative pi over 6 to pi over 6 secant squared x dx. And this is secant to the 4th x dx. So all said and done, our center of mass in the y direction, y equals the moment about x over the mass function. And so we're going to have 49 halves negative pi over 6 pi over 6 secant to the 4th.
Yes. Okay.
Excellent.
Thank you.
Need anything, email.
Yep, will do. Thank you so much.
Secant to the 4th x dx divided by 7 delta negative pi over 6 to pi over 6 secant squared x dx. 7's deltas cancel, so we're going to get 7 halves. So we can leave the 7 halves out. And negative pi over 6 secant to the 4th x dx over negative pi over 6 secant squared x dx. Let's make these integrals a little bit doable for us now that we have our setup here. So we get 7 halves. This is an even function, so I can take 2 times 0 to pi over 6 of secant to the 4th x dx. And downstairs I can get 2 from 0 to pi over 6 secant squared x dx. So I'm going to have 7 halves times, let's see, so secant to the squared downstairs is going to be tangent of x evaluated from 0 to pi over 6. And so now we really just need to learn about our integral upstairs. And our upstairs integral will be secant squared of x times secant squared of x dx over tangent x from 0 to pi over 6. Well, secant squared of x is tangent squared of x plus 1. I'm just going to focus on the integral here. Let's just be the integral of 0 to pi over 6 times secant squared of x dx. And this upstairs integral, oops, scrolled the wrong way. This upstairs integral will become 2 again, this is just the numerator plus 0 to pi over 6 secant squared x dx. Alright, this, if we let u equal tangent of x, then in du is secant squared of x dx. And the first integral becomes, well, tangent of 0 is 0, and tangent of pi over 6 is 1 over root 3. So this becomes u squared du. And this was our friend the tangent again. 0 to pi over 6. So our integral's not too bad now. We're going to get u cubed divided by 3 evaluated from 0 to 1 over root 3 plus tangent x 0 to pi over 6. If I bring the numerator back in, we get tangent of x from 0 to pi over 6. And if I remember correctly, there was a 7 halves hanging out in front of all of this. So let's do this evaluation upstairs here. U cubed is 1 over root 3 cubed divided by 3, put in the 0, that's 0, plus 1 over root 3. And downstairs I'll get 1 over root 3. All times 7/2. And a little mathematical playing. Let's get ourselves a numerical answer. So 1 over root 3 cubed divided by 3. Let's try, excuse me, let's try to clean this up a bit. 1 over root 3 is root 3 over 3 cubed over 3 plus root 3 over 3 divided by root 3 over 3. I'm going to try to make my maths a little bit easier. I'm going to make 7/2 plus one of these root 3 over 3's will cancel one of these. So that's root 3 over 3 squared divided by 3 plus 1, all times 7/2. And so I'm going to get 3/27 plus 1, all times 7/2, which is equal 27 over 27, 30/27. 7/2 times 30/27, or 7 times 15 over 27. That has a factor of 3 in it, so 35/9, which is the coordinate in the y direction. And so we have our center of mass at 0 and 35/9.